Welcome to the screencast for 6.3 square root functions. So a square root function contains the square root of a variable. So what it looks like is square root x. So keep in mind that we only can plug in positive numbers under the square root because literally the square root means two things are multiplied together. It's the same thing multiplied. So if I take a negative number and multiply that same negative, I'll end up with a positive. This is why we can't have negatives under. So it's not negative. And remember we talked about imaginary numbers. So if you put in a negative x underneath the square root, you'll get something imaginary. So when I'm trying to graph it, I only want the positive. I only want the real values of x. I don't want any imaginary. All right, so roughly what this is going to look like, I'm not sure if you've ever seen this before. It just looks just like this curve, kind of like you're trying to put your arm around someone. You know, here's your arm, you just smooth it. I don't know. It's a weird way to remember. All right, so here's the square root. This is what it looks like. So we're going to graph it by using a chart, XY table. So this is the parent function. And so we're going to just graph the absolute value over and over again. And all of them are going to be transformations from the parent function, meaning we can slide it up or down, left, right, maybe dilate a little bit, stretch it out, but otherwise everything is based on this one chart. All right, so I can't plug in any negative values, remember, because a square root is literally we're asking what times itself is this number. So if I take a negative and multiply by itself, it's going to be positive. So I'm going to start at 0. All right, so what's the square root of 0? Well, 0 times 0 is 0. All right, if I put in 1, square root of 1, well, 1 is equal to 1 times 1. Square root of 2, uh-oh, that's not very nice. 3, okay, so square root of 3, that's not nice either. 4, okay, square root of 4 is 2. Interesting, so we have 1 squared is 1, 2 squared is 4. What number is going to give me 3? All right, 3 squared is 9. So if I put in 9 square root is 3. All right, well, let's think 4. What would give me a height of 4, a y value of 4? Well, what is 4 squared? 16. But unfortunately, 16 as an x, like that's way, way off over here. We're not going to plot that. So let's go ahead, let's plot our values that we do know. So this is the ones you're always going to have, 0, 0, 1, 1, 4, 2, 9, 3. Those are basically the ones you're always going to be using from now on. All right, so 0, 0, 1, 1, 4, 2, 9, 3. All right, so let's go ahead and let's connect them in this nice curving shape. So that's exactly what I said it's going to look like. All right, you see the nice curving shape up here? That's what it looks like. Awesome. So from now on, like this is what the basic square root function is going to look like. This is the parent. I could, you know, if I had square root of x plus 2, that would mean I would move every single point up by 2. So this is not anything new because we've talked about transformations of a function before. So this is moving it up 2. If I wanted to move it to the left by 2, I would have to put it here, x square root of x plus 2. So notice inside versus outside of the square root. This is very similar to when we had y equals x plus 2 squared. It was this plus 2 right here that caused it to go the opposite way. It caused it to go left by 2. So this one I'm looking at in the purple, I want it, so normally it's x minus, x minus whatever number. So since there's a plus here, it's going to go the opposite direction of what we think. This is just transformations of functions. We went over this in chapter 2 with absolute value. We went over this in chapter 4 with parabolas. And now we're going over it in chapter 6 with square roots. So what I'm going to do, since this is the x plus 2, moving everything to the left by 2, I'm going to take all of my points, move them to left by 2. Take all of my points, move them to left by 2. All of my points over 2. This point over 2. So it looks like that. So Right, so I moved everything over by 2. So that's the difference of moving up by 2 versus over 2. And I'm just moving my points. I could also stretch it. I could vertically dilate it. Let's see, I can prove that this is what it looks like. Okay, so if I move this guy over, let's see if it lines up. Oh, that was the wrong one. Let's move that one. Oops. Okay, whatever, that's fine. Okay, I think that's it. Nope, okay. I was gonna try and move the maroon one over so that way you could see how it exactly lines up with the purple. Then it's exactly gonna line up with the pink if I move it up by 2. So it's just sliding it. It's a translation. All right, the last thing I want to talk about, get rid of these pink and purple guys. I want to talk about the domain and the range. So the domain is the X, the range is the Y. So what's my basic domain and range? So my basic domain, well, I don't have any X values on my left side, right? So I didn't plug in any negative X values. So it's going to go from 0 to infinity. So really my X is going to be greater than or equal to 0 because it's everything to the right of the Y axis. My range, interesting problem. There's no Y values less than 0. Notice they all are 0 or above. So Y is going to be greater than or equal to 0. Cool. So when you go about finding the domain and range, one thing you can look at is you can look at the square root of X. So whatever's in here has to be greater than or equal to 0. Since I only have an X inside this parent function, I know X has to be greater than or equal to 0. To find the Y values, well, you can also look at your origin, like, oh, I'm starting at 0, and it goes on to infinity. As far as X is concerned, starting at 0 goes on to infinity as far as Y is concerned. Awesome. All right, graph each function, identify the domain and range. So here I have square root of X plus 2. I believe I already did this a little bit. So I know this plus 2 here is going to mean I'm going to go to the left by 2. All right, so this is very similar to when we had the like y equals x plus 2 squared, you know, plus 4, blah, 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 blah. This is the vertical translation. And then this was going to be the horizontal. All right, so we talked about that a bunch already. So I know I'm moving everything left by 2. So there's 2 ways you can solve this one. So first, I'm going to show you how to do it with like a table, a chart. So I'm going to just list out my X and Y numbers. So I have 0, 0, 1, 1. Let's see, 4, square root of 4 is 2, 9, and 3. So you should be very familiar with these numbers. So I'm moving them all left by 2. What that means is all of my x's are going to be minus 2. I'm moving everything to left by 2, so I'm subtracting 2 from all of them. So then I have my new coordinates. So negative 2, 0, negative 1, 1, 2, 2, and 7, 3. Everything is moved over 2 places. Because remember, my original graph is 0, 0, 1, 1, 4, 2, 9, 3. Well, I didn't draw it exactly great. Let me just connect my line a little better. Okay, so it looks something like this. Then connect. So this gray is standing for the parent function, right? So the gray is just square root of x, but this maroon color is going to be the square root of x plus 2, because what that means is everything was shifted left by 2. So that's one way to do it, is using the table. So that's way 1 is with the table. All right, B, f of x equals square root of x minus 2 plus 1. So I'm going to do this one a little different, give you that option. So this minus 2 means I move everything to the right by 2. And then the plus 1, since it's outside of the root, I'm going to move everything up by 1. All right, so I can go ahead, I can plot my parent function. Let's see, 4, 2, 9, 3. Okay, so this is the parent function square root x. So every single one, I want to take my point, I want to go over by 2 and up by 1. So my new point is here. And then I take this point over 2 up 1. This would be here. Oops, wait. Over 2 up 1. Yes. And then this one over 2 up 1 is right there. This point over 2. Oh my gosh, up 1, so it's going to be right there. Okay. So let me just erase these little marks. Okay, so what this is going to look like. Oh shoot, did I not go over 2 up 1? Let's see. Oh yeah, right, it is right there. Okay. Oops. Oops. Go back. Okay. So then I just move it that way. So really what happened was my whole graph, this whole gray one, is moved over 2 places. Oops. 2 places. And I'm moving it up by 1, just like this. So it exactly lines up. Pretty exciting. That was the translation. Okay. So if I want to move my gray graph, which is my parent, I go over 2, up 1, and then it exactly lines up. That's my translation. Perfect. All right, so now what we're going to do, so that's way 2, you just go point by point. That's not ideal. You know, it might be a little easier because, you know, you only know those points, but I could also show I'd get the same thing if I would do the x and y coordinates, x, y. So my original points are going to be 0, 0, oops, 1, 1, 4, 2, 9, 3. Okay, so I'm going up by 1 every single time. So plus 1, plus 1, plus 1, plus 1. Going to the right by 2 every single time, so I add 2. So my new coordinates are going to be 2, 1, 3, 2, 6, 3, 11, 4. So let's make sure those are what our plots are. 2, 1. So that's right here. 3, 2. So 3, 2. 6, 3. 11, 4. So it exactly lines up. So either way would work. All right, I'm a little partial to this table because, I mean, it shows you really know what you're doing by, you know, shifting everything over. You don't even have to notice we didn't even plug into the original equation. We just took our values of our parent and then add or subtract whatever we needed. All right, domain and range. So for the left one, all right, so I'm looking at this maroon. The domain is going to be, well, if I take x plus 2, I know that has to be greater than or equal to 0. So I'm taking the part that's inside my square root. Solve for x. X has to be equal to, greater than or equal to -2. Yeah, guess what? Here's -2. So all of my x values to the right are going to be part of it. So x is greater than or equal to -2. So if you have graphed the function, you can easily tell what the domain is. But if you don't have the graph, this is the way you do it. You just look at what's inside the square root and set it greater than or equal to 0. The range, well, I don't have a plus or minus, right? I don't have like a plus number over here. So it's just going to be y is greater than or equal to 0. So notice I don't have any y values down here. They're all above the x-axis. Notice I have a y equals 0 and then everything going up, right? So I just keep going up. So y is going to be anything greater than or equal to 0. Here, let's try this out. So if I want to find my domain, I take what's inside the square root, so x minus 2, and I have set that greater than or equal to 0. So x is going to be greater than or equal to 2. Let's make sure that's true. Guess what? I'm starting at x equals 2 and then everything to the right of it, everything greater than it. So x is greater than or equal to 2. And then, oh my gosh, I'm shifting everything up by 1, meaning y is now going to be greater than or equal to 1. Everything is shifted up. Yep, that's my lowest. My lowest is y equals 1. And then I'll have all the numbers above it because this function doesn't actually go down. So y is greater than or equal to 1. You also can like look at the graph, see the lowest number. All right, let's try the other ones. So you can go ahead, try parts C and D, and then unpause the video when you're done. All right, so this one's a little tricky because it does have this 3 out front right here. So that means I'm going to be multiplying all of my y values by 3. And notice there was no addition, right? I'm not adding, then I'm not adding 3 or whatever. So I'm just taking whatever values I had, multiplying by 3. All right, so it stretches it vertically. It stretches it vertically. And then I have this, minus 5 here, so that means it's opposite of what we think. It means it's going to be positive 5, moving everything to the right by 5. So I'm adding 5 to all of my x coordinates. And then I just find my points. So if I would have drawn out my full graph, I mean, it would look something like this. It would just take a longer time to shallow out, right? It still looks pretty steep here. To find the domain, I take x minus 5 and set that greater than or equal to 0, solve for x. So x is supposed to be greater than or equal to 5. It is. Look, I start at x equals 5, and then everything to the right of it will be included. And then I'm not adding anything to the y over here, so that's why I can keep it greater than or equal to 0, right? Because I still start at a y height of 0, and then I have all of my values that are above it. Awesome. So go ahead, try the next problem. So right away, we notice that the negative sign out front means it's flipped. The plus 4 means it goes to the left by 4, and the negative 6 means down 6. So I listed out all of my original parent functions in gray. Right, so when it says left by 4, well, that's x. X is left and right. So I went ahead, I subtracted 4 every single time to find my new x coordinates. And then I have this negative, so that's flipped. So that's why I went and then I put a negative sign in front of all of my y, oh my gosh, in front of all of my y values, right? And then I had to minus 6. So I made all my y values negative, effectively flipping them, and then I subtracted 6. So this is going to be a real interesting looking graph. So I have negative 4, comma, negative 6, negative 4, comma, negative 6. Okay, that's right there. Negative 3, comma, negative 7, okay, 0, comma, negative 8, 5, comma, negative 9, so I gotta scroll a little bit, let's see, 5, comma, negative 9, okay, so it goes like this. So not only did my parent function, let's try it. So not only did my parent function flip over, I don't know how that happened, okay, so this is shifted to left by 4. So I'm going to shift this to 4. 1, 2, 3, 4. And then down by 6. 1, 2, 3, 4, 5, 6. And then I have to flip it, meaning I have to, so flip it over like this line. Flip it over. It's reflected across. And that's how I got it. So I moved it over and then moved it down and then flipped it. So I moved it over left 4, down 6, and then I flipped it, and that's how I'd get the purple one. Okay, so let's see. If I want the domain, I set x plus 4 is greater than 0, so I'm just taking the inside part. Solve for x, so x is greater than or equal to negative 4. Is that true? It is. Check it out. Here's my x value at negative 4, then everything is to the right of it. So my x value is greater than or equal to negative 4. Greater than or equal to negative 4. But what about my y? I am down 6, but that's the highest. So y is going to be less than or equal to negative 6 because it's everything less than negative 6. So that's it for the lesson. We did a bunch of transformations. Here's the 1 through 9 odd is the problems. So we do have these other exercises we can go through, not too hard. We're not going to be doing the inequalities. So if you need more practice, instead of saying, greater than, you could just have these be equal to. But yeah, that's it. Good luck with the quiz.